Hello, today we're going to be talking about mortgages, okay, and so basically paying off loans. And this is one of the most practical applications of, well, it's actually a formula that we're going to derive, and it's based on simple interest, exponential functions, the sum of a geometric series. All these things are going to come into play to come up with a formulas, various versions of the formula for mortgages. Okay, so here's the basic idea. And by the way, this is something that we all basically either have a mortgage, have a loan. Most of us can't afford to go out and buy things like a house or sometimes even an automobile and just pay cash for it, particularly something huge like a house. And so you take out a loan and you make monthly payments. So in the case of a house loan, sometimes there are other things involved in the payment, including things like interest. Sometimes there's some private mortgage insurance, there's homeowners insurance. Sometimes their taxes and stuff are included, all that into an escrow account. What we're talking about here is just the part that goes to principal and interest. Okay, like when you take an automobile mortgage, that's everything you do is for your principal and your interest. So let's say we're taking out an automobile loan. What you do is you make monthly payments, and what happens is you have a balance that you borrow. They give you that money up front, but you got to pay it back plus more. So basically the bank buys your car for you. You have to pay the bank back. And every month they figure out a simple monthly interest, and they add that to your loan balance. Then you make a payment. Well, your payment has to cover all your interest and some of your principal. And it's designed in such a way that the payments are done in equal amounts, and so that balance will eventually go down to zero at a fixed time. Now, the way this works out is nearly all of your first payment is interest and just a little bit is principal. And the next one, though, you got a little smaller balance, so there's less interest, but your payment's the same, so you still pay all their interest, but a little bit more of the principal, and so forth. And by the time you get to your last payment, there's very little interest, and it's almost all just the principal, just paying off what you actually originally borrowed. Okay, now some basic letters we're going to use. T is going to be the time since the loan was taken out. In months, we're going to assume monthly payments. You could adjust this to any time, yearly payments, daily payments, weekly payments, whatever. Just remember your R and your T have to be consistent. So if you're doing it in daily payments, then your rate must be a daily rate. If you're doing it in and then the N and the M, everything would be per day instead of per month, or if it's per year, whatever. Okay, I'm going to do things here per month, which is sort of a typical way of paying off loans. So T is going to be the time since the loan was taken out in months. P is the principal, or the original amount of the loan, what they actually gave you in the money. R is the monthly relative interest rate. Okay, remember this needs to be adjusted per month now. A is the amount in the account. That's the balance due at any particular time. So that's the payoff amount. If you were just to go in and say you were to hit the lottery or something, and you just want to go pay it off, that would be the amount you have to pay it off. M is going to be your monthly payment. N is going to be the total number of payments needed to pay the loan off. So N is actually a time as well, but it's the time specifically to when you're going to have a zero balance. So what you do is you take each month. What you do is you take your balance at the beginning of the month, of the previous month. It's been sitting there earning interest for the bank, charging you interest all month. So you multiply by 1 plus R. So you multiply that by the R, and that gives you your interest. Add to the original amount. Well, that's going to be 1 plus R. But then you make a payment of M. So that's subtracted off. So now you got a new balance. Take that new balance, multiply it by 1 plus R, and subtract M. And each time we're going to be multiplying by 1 plus R and subtracting M. We're going to see after we manipulate this a little bit that we're going to get a sum of a geometric series. And remember, I promised back when we derived the formula for a sum of geometric series in an earlier section that we were going to come back to that. And here are the details. Let's see if we can take a look at this. So your amount at time 0 is P. Then usually you go, let's say you go 1 month before you make your first payment. So payments are at the end of the month. That's what we're going to assume is pretty normal. So your amount at the end of the first month is P times 1 plus R, but then you make a payment of M, so you subtract M, and that's your new balance after you've made your payment at the end of the first month. Okay, the end of your first payment. Now what do you have for your second payment? Well, you take that amount, P times 1 plus R minus M, multiply that by 1 plus R, and subtract M. Now I'm going to distribute the 1 plus R, that's P times 1 plus R square, then you got minus M times 1 plus R. Now I'm going to group the last two terms and factor out the minus M, and I'm going to rewrite the order as well, and write that as minus M times 1 plus 1 plus R. Alright, let's continue on. So that's your new balance at the beginning of the at the end of the second month, the beginning of the third month. So take that. That's the amount that's going to be earning interest for the bank for the next month. So that the balance at the end of the month before the payment would be just multiply that by 1 plus R. So we're taking the P times 1 plus R squared minus M times 1 plus 1 plus R times 1 plus R, and then we're going to subtract our payment because we're going to make a payment. Well, again, I'm going to distribute the 1 plus R, and now we have P times 1 plus R cubed. Then I'm going to have, then on the inside of the second one here, I've got minus M times 1 plus R plus 1 plus R squared, and then we have the minus M at the end. And I'm going to factor an M out of all that, minus M, and I get P times 1 plus R cubed minus M times 1 plus 1 plus R plus 1 plus R squared. And if you look at the next month, you're going to get P times 1 plus R to the fourth minus M times 1 plus 1 plus R plus 1 plus R squared plus 1 plus R cubed. The next month, it'll be P times 1 plus R to the fifth minus M times parentheses 1 plus 1 plus R plus 1 plus R squared plus 1 plus R cubed plus 1 plus R to the fourth, and so forth and so on. So the nth month will look like, or the teeth month, after you've made your teeth payment, would be A sub t, or A of t, is P times 1 plus R to the t, minus M, and then we have this sum, 1, then plus 1 plus R, plus 1 plus R squared, plus 1 plus R cubed, and the last one, if you notice, the power is 1 less than t, so it's 1 plus R to the t minus 1. But the first one is 0 here, so we actually have t things we're adding here together. So these are, if you write R, 1 plus R is the base, you've got 1 plus the base squared, plus base cubed, so forth. This is exactly this part right here in this last parentheses, 1 plus 1 plus R plus 1 plus R squared, and so forth, up to 1 plus R to the t minus 1. That's a sum of a geometric series. So now we can use our formula for a geometric series to rewrite the last part. So you still got the first part, A sub t equals P times 1 plus R to the t. You still got your minus M. But the rest of it can be written as the base to the t power minus 1 over the base minus 1. That's our sum of our geometric series. The base is 1 plus R. Now in the denominator, 1 plus R minus 1 is just R. And so now we have a formula for the that relates all of our variables that doesn't involve some kind of extended sum. Okay, so we have a closed form here. So the amount is the principal, the amount that's the payoff balance after you've already made t payments. Immediately after making the t payment is P times 1 plus R to the t minus M times parentheses 1 plus R to the t minus 1 over R. So in the big box there, you see there's your payoff balance. So if you've done this and you've been paying for a while, and let's say all of a sudden you get out and you may get a new job, and you graduate from college, get a new job, and get a nice signing bonus, and you want to go ahead and just pay off your car balance. You can use this to figure out how much you'd have to do to pay it off. Now let's see if we can solve this a little bit more. If we plug in the specific t value, which is n, which is the total number of payments, we know that the balance at that point after making those total number of payments should work out to be exactly 0. So we plug in 0 for a sub t and n everywhere we see a t. I'm going to add this expression here, and I'm going to get this expression, m times 1 plus r to the n minus 1 over r equals p times 1 plus r to the n. So this is going to be the relationship between the total number of payments, the monthly payment, the monthly interest rate, and the principal, the amount we borrow. Now I can solve this for the various variables. We're going to solve it for n, p, and m. We have algebraic techniques to do that. So the first thing is, well, how do you figure out your monthly payment? Well, I'm going to multiply both sides by r and divide by 1 plus r to the n minus 1. And so we get p times r times 1 plus r to the n over 1 plus r to the n minus 1. And I'm going to, since I've got a 1 plus r to the n in top and the bottom, I'm going to multiply top and bottom by 1 plus r to the minus n and clean the formula up just a little bit. So that'll cancel out the 1 plus r to the n in the top, leaving me just pr in the top. And the bottom, that'll be 1 minus 1 plus r to the minus n. So there's a nice formula in the box there to figure out your monthly payment. Very useful little formula. So you'd use this version of the formula if you know the principal, you know the monthly interest rate, and you know the number of payments you're going to make. You can use this to solve for your monthly payment. So next time you go in to buy a car or something, you could use this right here to figure out what your monthly payment is. Okay, well, suppose we want to solve for the principal. This might be a healthier way to go shopping for an automobile. So take this expression here, divide by r, multiply by 1 minus, well, multiply by the whole denominator there. And so we get m times 1 plus m times 1 minus 1 plus r to the minus n over r. That's all times m, and that is your principal. Now this you'd use it in this version right here if, for example, like I said, this may be a healthier way to go buy a car rather than just go out and test drive whatever's out there and spend a lot of time and then find out you can't afford it later on. Decide up front how much you can afford for a monthly payment. That's your M. Maybe you go to the bank or whatever, and or you see the advertised rates, and you know what kind of percentage rate you can get on a loan, and you know how many months you're going to finance it for. Let's say you want to stretch it out, maybe make 5 years. That'd be 5 times 12, 60. So N would be 60 payments. You can get your interest rate. Let's say the interest rate is 6% a year. Well, you're going to divide that by 12 and get 0.5% or 0.005 for R, because it needs to be a monthly rate. 6% compounded monthly a year corresponds to 0.5% per month. And then you figure out what you can afford for a monthly payment, put it in for M, and now you see the most you can afford to pay for a vehicle would be the P, or at least the most you can afford to borrow. So that's after you've paid all of your whatever your taxes and maybe whatever down payment you've made. Then what's left is what you actually have to borrow, and this could tell you how much at most you can borrow. Okay, so there might be no point in going out and driving a really super expensive car when you can only afford something that's quite a bit cheaper. Unless you just want to go for the test drive. Now, we can also solve for Enum. This is a little bit harder to do, but we can use our some of our properties for solving exponential equations to solve this for n. Now, we got n's on both sides, so the first thing I'm going to do is multiply both sides by r. Then I'm going to distribute the m on the left, and so now I have the third line here, m times 1 plus r to the n minus m equals pr times 1 plus r to the n. Now, I'm going to get the add m to both sides, so I'll get the m on the right. Subtract pr times 1 plus r to the n, so that gets everything that's an n term on the left. Notice they're both 1 plus r to the n, so I can factor that out. 1 plus r to the n, and that leaves m minus pr. Divide both sides by m minus pr, and I've isolated my exponential. Now I'm going to take a natural logarithm of both sides, because I got to get my power bound. I'm going to throw a log at it. So the property of logarithm says I can pull that n out front, and then divide by the natural log of 1 plus r, and now we have in the box the formula to solve for the number of payments. So where might you use this? Let's say you're going along here and you want to, say, refinance. So you've got a house and you've been making payments at a higher rate. You want to come in and refinance, and this time you know how much you owe on the house by the formula up above. This formula up here would tell you how much you owe on the house, right? And so you could use that formula and figure out so that's your new principal, what your new loan's going to be. You know what your new loan, hopefully at a lower interest rate perhaps, so you're going to refinance at a lower rate, and you can put in that R there. Again, you want to make it a monthly rate if you're going to figure monthly payments. M is your new monthly payment that you can afford. Maybe things have gone along and you can afford to maybe make a little higher payment, get that loan paid off a little faster than you, maybe you're making more money now than you did back when you first took out your original loan. So now you put your new monthly payment in there. Then figure this out, then this will tell you how many payments, how many months it's going to take for you to go ahead and pay the loan off. So, summarizing, here are the formulas that we had. Okay. The amount after T payments is P times 1 plus R to the T minus whatever the payment value is, M. Then 1 plus R to the T minus 1 over R is multiplied by that M. And T is the number of payments. R is your interest rate per payment period. So again, if it's monthly, T is in months, M is a monthly payment, R is your monthly interest rate, P is the principal, and A is the balance that you have after making that Tth payment. If you let N be the total number of payments for the loan, then the monthly payment is PR over 1 minus 1 plus R to the negative N. Take the same formula there and just solve for P. P is M times 1 minus 1 plus R to the negative N over R. Take the same formula and solve for N, and we get this last expression. The only one that we don't know how to really solve for is R, and we could solve for it using some calculator techniques, some approximation techniques, but we don't have any nice algebraic way of solving for the R. Okay, so we could solve some problems like this. Suppose you're buying a car and you want to plan on financing $21,500. You can get an interest rate of 4.9% per year, compounded monthly, and you're financing for 4 years. What's your monthly payment? So you're going to try to find your monthly payment. You just need to figure out the right numbers. Plug in this formula here for M. Solve for M. Next, suppose you're buying a car and your budget allows a maximum payment of $380 per month. You can get an interest rate of 5.9% per year, again compounded monthly, and you're financing for 5 years. Remember, you got to do monthly payments. You got to change everything to months. Your interest rate has got to be a monthly rate. Your time has got to be months. What's the maximum amount you can borrow and stay within your budget? Well, which one are you going to use? you're going to be solving for P, so you're going to use this version right here that's solved for P. Okay, suppose you bought a car at 9.5% annual interest and you financed $24,550 for 5 years. What would be your monthly payment? Now let's say that after exactly 2 years of payments, so how many payments is that? 24 payments. You graduate from school and you land a great job. Hopefully that's going to happen to all of you. You'll get out of school, land a great job. You can afford to accelerate your payments. So you still owe, find out how much you still owe after 24 payments. Now take that as your new principal, okay, and you decide to increase your monthly payments to $850. That should be more than what we figured your monthly payment was before. How long will it take you to pay off the car? Well, now you're doing it, once you found how much you, so to do that one, you're going to use this formula, the A formula at the top, to figure out what your balance is after you've made whatever, 24 payments. And now you're going to go back down here, and the interest rate's going to be the same, but we're going to put in the payoff balance that you found out above is going to be put in for P, and with monthly payments, our new monthly payment, and then solve for how many months it's going to take. So use that last one. Okay, so go ahead and work those out, and when you work those out, come back to the video. Come back to this notes. Now it turns out that mortgage calculations are actually built in the TI-84. This is just totally cool. Okay, so TI-84 is a useful application. You find it by pushing Apps and choose Finance. That would be on a TI-83 Plus and a TI-84. The older TI-83 without the plus, it's right on the home screen there, right on the keyboard, listed as Finance, which is second, and then the X inverse key, X the -1 key. Sorry, this application is not on a TI-82, so this is a really cool application. It's probably worth the difference in price of an 82 and an 83. But anyway, this is cool. So you choose this, and then you get several different things there that come up, and the one we want to use is the TVM solver, time value of money. And you get this screen on the right. Well, N is the total number of payments. The box is over, I think, a 4, so it's probably a 4-year, 48-month loan. I is your interest rate, but notice it's a percent. So this is 4.9%. That's your percent per year, not your monthly rate. So there's a couple things about that that are a little strange. It's not your monthly rate, it's your nominal rate, and it is a percent already, so you don't change it to a decimal. So when I put that in, the way I've got it written, that's actually 4.9% per year compounded monthly. PV is the present value or the principal value, and you type in how much you're going to borrow there. The payment is there. Notice the payment's going to be negative because that makes sense because, well, because it's money out of your pocket. The principal is money they actually give you, so that's a plus. The payments you make, that's the minus. Okay, and the FV is the future value, which is was eventually going to be 0. P divided by Y is payments per year, which is 12. C divided by Y is conversions per year. So that's how many times they figure the interest each year is conversions per year, and your payments per year is also 12. So usually, actually, if you change payments per year, conversions per year will change automatically. Most of the time it's going to be monthly, so we do that. You can choose to make a payment at the very beginning and then go from there, or make a payment at the end of each period, and the end is the normal way to do it. So normally you're going to have that set on N. Normally you're going to have the last two set on 12, 12, and N. Those for the last 3 lines there. So we can use this. The way we do this is we fill in all the numbers here except for one, and any one we can leave out. The N, the present value, future value, payment, even the interest rate you can leave out as an empty. Then press solve, which is alpha and enter, and it will figure this out. So here's an example worked out. So what is the monthly payment on an automobile loan at 6.8% per year? Financing $27,900 for 4 years. So you just enter this in. Well, it's 4 years, so it's 4 times 12. And you can actually, on the end, actually type in 4 times 12 to get 48. You put the interest rate is 6.8. Okay. The amount you're financing is the PV, 2,000 or 27,900, and the future value is 0. 12 payments per year, 12 conversions per year. The end. Notice I left payment blank, and I put the cursor on the payment and hit solve, and it comes back and tells me my payment's going to be $665.51 a month. And you can just as easily solve for any one. Okay, so let me pull this up and show you. So that's apps, and it's the very first one, finance. At least on mine it's the first one. And TVM solver, so we hit enter. And let's go back and work a couple of the problems up earlier using this here. Okay. You're buying a car, you plan on financing $21,500. So that's your principal value. And you're going to get an interest rate of 4.9% per year. So it's not 0.049, it's just 4.9. And you're going to finance for 4 years, so it's 4 times 12. Notice you can actually just do 4 times 12, and it'll figure out it's 48 for you. Of course, that's easy enough to do in your head. The payment we don't know. The future value is 0. We're going to make, no, not 1 a year, we're going to make 12 a year. Notice that changed the other one automatically. And the one we don't know is our payment. So I'm going to leave my cursor there. I'm going to do alpha, enter, and it'll solve it. So I need to pay $494 and let's see here. $494.16. Alright, so let's do the next one. You're buying a car, your budget allows a maximum payment of $380. So that's going to be the payment. So it's a payment, so I'll do it negative. Negative $380. You get an interest rate of 5.9 that you got to pay. Okay. You're going to, we don't know this one. This is one we're going to solve for. Principal value, we'll come back to that in a minute. I got to put something there. Come back to it. How long? 5 years. 5 times 12 is 60. 60 payments. Future value 0, 12 per month. What we don't know is the payment. So whether there's a number there or not doesn't matter. I can delete it or whatever. Or just, it can be whatever. It doesn't matter. If I'm on that one right there and hit solve, it'll replace it with the correct answer. I'm going to go ahead and just delete it out. Okay, and then alpha, enter, will solve. And so we can afford to take out a loan for $19,703.07 with that to stay within that budget. Of course, that's how much we borrow. Any other things that we have for down payments got to be on top of that. And of course, that doesn't mean you have to borrow that much. That's just saying that's the most that we can borrow. Okay, so there's no sense in going out and shopping for a car that's a $30,000 car or a $100,000 car if we can only afford this much. All right, let's go to the next one. Suppose you buy a car at 9.5% interest and you finance, let's see, okay, so let's go through here. 9.5% interest, that's here. And, yeah, this is not now. Hopefully we can get better interest rates than that now, but you finance $24,000 550. That's our principal value. 5 years, that's 60 months. What's your monthly payment? Okay, future value 0, payments per year. Okay, right here we're going to redo this one. And the payment is 500. Let's get where you can see that all. $515.60. That's your monthly payment. So let's say exactly 2 years after you do this, after 2 years of payments, you graduate from school, land a new job. How much are you going to have to do to pay off the car? How much is still owed on the car? Well, let's keep that payment the same, but let's change the years to not go to 60, but to go to 2 years, 24 payments, and let's solve for what that future value is going to be. And so we just go right here and solve for the future value. This is really cool. And so, how much do we still owe? We still owe $16,095.79. Someone doesn't seem right on the sign there. No, that was right. That was the right thing to do. So that is the right thing. But you owe still $16,095. Okay? Alright, now, suppose you want to increase your monthly payments to $850. How many more months will it take to pay it off? Okay, so what I have to do is now the new principal is the $16,095.79. Our new payment, negative, what did we say it was going to be? $850. So our new budget allows us to make it more money, so we can do a new budget. Oh, that should be a negative. 850. Future value, now the future value is still going to go back to 0, and we don't solve for how long it's going to take. How many payments would it take? It may be a fraction here, 20 point something, so 20 full payments and then a partial 21st payment. So in 21 months, you'll have it paid off at this new rate. Isn't that cool? That's totally slick that you have this little thing. So, you know, when I go shopping for a car now, if I'm going to talk about financing, I can work this out like this. Now, what I want to show you though is something interesting. Let's say you've got a $20,000 car, and let's say you're going to finance for 5 years, 60 months, and let's say right now you can get a 4% rate. Okay, look at what your payment's going to be. $368.33. Well, how much are you actually paying for the car? You pay that 60 times. So you finance $20,000, but you're actually paying $22,099.08. So you're paid almost $2,100 in interest, and it's going to take you 5 years to pay this automobile off. Now I want to show you something else that we can do. Suppose instead, let's see, what's that? $368.33. Let's say $369. So if we can go here and instead of paying that, save that amount of money each month. If we start with 0 and actually save that amount of money, $368.33, let's just say let's just say 369. And we want the future value to be the 20,000. And we're not going to be able to get as much interest if we put it in a bank. Let's say we can get just, if we're lucky, 1%, let's say, these days. How long would it take you to save up enough money to buy this car outright without having to do it? Let's see. Let's figure this out. Only 55 months. Okay, so at this difference here, you can, in 55 months, you can save up enough to buy the same car, and notice you paid a lot less. 369 times 55 months. You've paid, well, actually not even, actually should be less than that. Let me go back and look at that. It's supposed to be minus, let's see here. Yeah, that's it. 53 months. So then at 53 months times 369, 53 point something. Notice that you've actually spent less than $20,000, whereas the other way you've spent quite a bit more, and you know, it's paid off faster. So basically, you can save yourself a whole lot of money if you can get that, if you can sort of stay with some old car for a few years and then pay cash for, save up, put back in a savings account that earns interest, or even if it doesn't earn interest, just put back in a savings account the money that you would have been putting for a payment. You're going to be able to save yourself a lot of money, and that first time you do this, it's going to be a little difficult because you're going to have to stay with an older car for a while, but then you can start paying cash for a vehicle, and you'll save yourself a lot of money. So this is one way you can save yourself quite a bit of money. The other thing is credit card debt. Let's talk about that just a second. Be very careful about getting yourself into very much credit card debt. You should be paying, you can actually get credit cards that pay cash back, and you can actually earn some money on your purchases if you pay them off every month. Okay? But I've seen credit cards that could be as, I've seen some as high as 21%. Okay? And let's say you go on and you borrow $2,000 on a credit card. Okay? And you want to eventually get it down to zero. How long is it going to take? Let's say you're going to make $50 payment. Well, let's see. Usually it's a 2% minimum payment. So 2% would be $40. Let's say you make a minimum payment of $40. How long is this going to take you to pay it off? Okay, 120 months, 10 years to pay that off. Isn't that ridiculous? It's just, and in the meantime, you've paid, you know, that $2,000 that you put on there, 120 months at 40 months. You've paid $4,800. You paid $2,800 in interest on something that you only really should have cost you $2,000. So the moral of the story there is be sure you pay off, especially high interest rate loans, very, very quickly. Preferably don't even take them out. Okay, pay cash for stuff or get a credit card and then use it, but pay it off each month. Because credit card debt like that can kill you. And in fact, if this is a little bit smaller payment, then you may never pay it off. It'll never be enough to cover even the interest each month, or just the interest would be there. So, be sure that you pay that off much, much faster. Okay. So credit card debt especially can be a very, very big problem. In fact, I think credit card debt was at least as much a problem as the housing debt crisis that we had that got us into this tailspin of our economy that we've been in for the last many years now, and trying to pull out of it. We've been recovering a little bit, but we're pulling out of that. It's because people were buying more than they could afford, both in terms of credit card debt and their house loans, and eventually that kind of collapsed on us. So be sure that you can use this application now to help you sort of do some planning and figure out what you actually can afford.